Okay. Start. So module 1 is over. Okay. So we'll start with module 2, which is related to the economic dispatch. So first we will start with when losses are neglected. In the second case, we will see how losses are included. Like first is losses neglected, losses included. Okay. And the third part is how to calculate the losses. And the last part is directly from the load flow analysis compute the losses. Okay. And include that in economic dispatch, which will result in optimal power flow. Okay. So these are the 4 classes that we will cover. Right. Okay. So these are the 4 classes. For in 4 classes, this module will be complete, and this is the easiest module in PSOC. So if you want to score marks, you can count on this module. Also, from gate perspective, this is the easiest part. One question you will get from economic dispatch, but it is very easy. Okay, if you understand it, you can solve it. Okay, that is not much different. Okay, so what are the 4 parts? The 4 parts are, first we will see how economic dispatch is performed without including the losses. Then we include the losses, and these 2 we will solve as an optimization problem. These 2 we will solve as an optimization problem. Okay? This is basically an optimization problem, sir. And we will see one analytical technique. We will see one analytical technique to solve this problem. Note down. Light also. Yes. Okay. So basically we are dealing with optimal operating strategies for power system. Okay. This is mostly applicable to the conventional power systems where the major portion of the power was supplied by energy was supplied by coal-based power plants or fossil fuel-based power plants. So our objective is to minimize the utilization of fossil fuels so that the cost is minimum. Okay, and also include hydroelectric power so that it offsets the requirement of the coal depending on the availability of the water. So determining which energy units to commit and what their individual megawatt and megawatt rating should be falls under the general topic of economic dispatch. Okay. So what is the generation mix? A typical utility may meet with daily load demand in a number of ways. The base load is carried by the generator that run at 100% capacity on a 24-hour basis. That's the base load. Okay. What is base load? Which is constant throughout the day. That is the base load. Now, immediate or controllable generation run most of the time but do not necessarily fully loaded. Okay, so these are known as spinning reserves. Okay, so these are known as spinning reserves. Okay, and these are known as the base load units. What units can be used as base load units? What units are used as base load units? What units are used as base load units? For the electric power generation system, generation, transmission, distribution, what units are used as base load units? Which one? What units, generating units, are used as base load units? How many kinds of power plants you know? Hydro, coal-based, thermal, nuclear. Okay. Ideally, nuclear power plants are base load power. They cannot work as peak load plants. They are used only as base load plants. Also, large capacity hydro can be used as base load plant. Okay. But in our case, also we use coal-based power plants or fossil fuel-based power plants are base load plant. In India, most of the base load is supplied by the coal-fired thermal power plant. And what is a controllable load? That's known as spinning reserve. So what is a spinning reserve? Spinning reserve means, suppose there is a 500 megawatt generator and it is running at 300 megawatt. Then 200 megawatt is available for supplying whenever the requirement is there. And the third kind of capacity is known as the peaking units. Peaking units are mostly hydro plants and also gas-fired power plants. Okay, because they can be started very fast. Okay, a typical thermal power plant requires 8 hours to come from cold state to on load, whereas a hydro power plant takes only 4 minutes. You simply open the gates, water comes in, within 4 minutes you are ready to synchronize. Okay. Similarly, gas-fired power plants also, they are very fast. Okay, so those are the peak load plants. Now the energy cost is calculated based on rupees per hour or rupees per megawatt hour. Now one question: solar PV-based solar power plant, is it peak load or base load plant? It's a base load plant. Okay. So, what are the types of this optimum operating strategies? The first one is economic dispatch. Which thermal generator you are going to run so that the use of coal is minimum. The second one is hydrothermal scheduling, where how to use the available water resources so as to minimize the coal-fired power plants. And finally, unit commitment, which deals with day-to-day scheduling of the plant, hour to hour, minute to minute, 10 minutes to 10 minutes scheduling of the plant, that is unit commitment. Which unit should be committed first? Okay. So start with the performance curves. So these are the basic performance curves of a coal-fired thermal power plant. What is input-output curve? This is the curve for the thermal plant and is a plot of the input in BTU versus power output in the megawatt. Okay, so how much coal you are actually putting in to get unit amount of power. Okay. The second one is heat rate curve. This is a plot of heat rate versus output in megawatt. The heat rate is the ratio of fuel input in BTU to the energy output in kilowatt hour. This is with respect to, here it is in megawatt, one axis in megawatt, here it is in kilowatt hour. Okay. The slope of the input output curve at any point, the reciprocal of heat rate is known as fuel efficiency. Okay. Next is incremental cost curve. It is a plot of incremental cost versus output in megawatt. The incremental cost is the product of incremental fuel rate and fuel cost. Okay. Unit of incremental cost is rupees per megawatt hour. So just write down these units because these we are going to see. Rupees per BTU. Any doubts? Who is talking? Any doubts? Write down the units. This is the theoretical method, okay, of economic dispatch. Now you have to solve the problem. Okay, after I give you the formula, you have to solve the problem. So be careful. Okay. So these are those curves that I talked about: input-output curve, heat rate curve, incremental fuel rate curve, and incremental cost curve. Okay. Draw the curves only. Draw the curves. Draw the curve. Draw the curves with axis level. Heat rate in BTU per megawatt hour, okay, or kilowatt hour. Heat rate in BTU per kilowatt. BTU is the old unit of thermal energy. Okay. So this is BTU thermal unit per hour versus output. Heat rate BTU per kilowatt hour versus output. Okay. And the third one is BTU per megawatt hour versus output, which is incremental given that curve. Okay. And for our case, see, the first three curves are the steps, but we are interested in only the last curve. We are interested in only this last curve. Okay. So draw this incremental cost curve. Okay. So this is the most important curve that we are going to deal with. Okay. So what is incremental cost curve? This is the cost in rupees per megawatt hour versus the power output in megawatt. Okay. So this curve is actually a quadratic curve. Okay. The most widely used approximation for this curve, is a quadratic function. Okay. Noted. The cost is given by, the total cost is given by AI plus BI PGI plus CI PGI square. Okay. And the incremental cost is given by the slope of this curve, which is BI plus 2CI PGI. Okay. We differentiate it with respect to PG. So this is the total cost, this is the incremental cost. Write down this formula. Total cost is an approximation of the curve, is a quadratic approximation of the curve, and the incremental cost is given by dP by dP, dFi by dPi. Okay. Remember it. The fuel cost curve is approximated by a quadratic function, and the incremental cost is the differential of that quadratic function. Clear? Keep that in mind. Which one? Third curve is not very important. We will see that later. Okay. This is the only curve that is important. Those three are only the steps to get this curve. Okay. No one is going to ask you those curves. Next. Now this is the, I think you have read one subject on optimization. Okay. Right? So I think optimization and soft computing you have read. So what is optimization? Maximization or minimization, right? That is optimization. Subject to, you can have a unconstrained optimization problem where there are no constants, and you can have a constant optimization problem where you have constants. Okay. So you might have used some analytical as well as soft computing based methods to optimize. So what analytical methods you have used to optimize? What are the methods you have used for optimization? Which one? And column integration. Then zero left. Okay. Next. Hill climbing. Okay. Next. So these automation techniques, except neural is not exactly an automation technique. Okay. method used to solve optimization problems, not exactly technique. So all the other things that you have said are known as the what? Soft computing method. So now we are going to see one analytical method. So this method is known as Lagrange's method. This method is known as Lagrange's method. Okay. So look here. What is our objective? To minimize. Write down this. To minimize the total fuel cost. Don't talk. Write this. To minimize the total fuel cost, which is the summation of the cost of individual generators. Okay? So what is the total fuel cost? The sum of the cost of individual generators. Right? Objective function. Right? All of you. Write the objective function. Minimize total fuel cost, which is the summation of all the fuel costs subject to power balance constant. Total generation should meet the total demand. Okay? Okay? Write down the objective function and the constant. Okay? Okay, so this is our objective function with the constant. Now what is the method of solving it? The method is known as Lagrange method or known as constant parameter optimization. What we do? We form something known as a Lagrangian, which is simply the objective function ft plus one parameter lambda known as the Lagrange multiplier lambda into the constant. Okay? So we get the Lagrangian as the objective function plus the Lagrange multiplier into the constant. Right? So this is one step of applying this Lagrange method. Okay? So we have created one augmented function. This L is known as one augmented function. Okay? Next. What is the basic technique you know how to minimize and maximize? By differentiating. Right? By differentiating and putting that equal to 0. Okay, we will do that again now. So our method of optimizing this will be, okay? So we take partial derivative of the augmented function or the Lagrangian. Okay? So step 2 is get the partial derivative, take the partial derivative of the augmented function or the Lagrangian. Why partial derivative? Because you might have so many generators. Okay? So we have to take the derivative with respect to that particular generator for which the cost is there. For example, del Fi by del Pgi. So there is no meaning of del F1 by del Pg2 because F1 is the cost of generator 1 only. Okay, that's a partial derivative. So when you take the partial derivative of the Lagrangian with respect to Pgi, we get the constant. Okay. This is equation 1. This is the first equation. And when we get with respect to lambda, we get the second equation. Okay, this is the constant. Okay, when we take differentiated equation with respect to lambda, we get the constant. And when we take differentiated with respect to Pgi, we get this. Okay. So we get two equations. We get two equations. Right? And our objective is to know Pgi and lambda. Our objective is to know Pgi and lambda. This is not exactly two equations you can say because we have several equations. Okay? One set of equations. Okay? Now from these two equations we get this very simple result. That is dou Ft by dou Pgi is equal to dou Fi by dou Pgi. This can be written as dFi by dPgi because differential of one generator is available only for the same generation. Differential of the cost of one generator is dependent on the generation of the same generator only. Okay, so that is equal to lambda. Okay, so this is the solution. So from where you have got this? From here only. Okay, if you solve both, this is basically the constant only. It is not being used. Only you are using this. From here only you are getting. So what is the meaning of this? Try to read the last line. Next we will solve the problem. So read the last line. Read the last line. And then I will ask, what is the condition for optimal operation? What is the condition for optimal operation? Ratio not loss. What is there? Dou F by dou PG. What is that? That is known as incremental cost. Because on the top you are getting the total cost rupees, and on the numerator you are getting the output megawatt. Okay. So that is actually rupees per hour. Rupees per hour divided by megawatt, which is rupees per megawatt hour. That is known as incremental cost. Why? Because what is the cost incurred by increasing the generation by 1 megawatt. So that's why it is incremental cost. So the answer is, to obtain the optimal condition for operation of the generators, we have to equate the incremental cost. Yes. So when you are given a problem, find the optimal schedule, what you have to do is you have to equate the incremental cost. Okay, and this is the condition only when the transmission losses are neglected. Okay. Now we will apply that to the economic dispatch problem. So we have decided to use the quadratic approximation for the fuel cost, which is AI, BI, PGI, CI, PGI square. Incremental cost is given by differentiating that. VI plus 2CI PGI rupees per megawatt hour. Now, from substituting the power balance equation 2 in 8, okay, what is power balance equation? What is the power balance equation? The power balance equation is summation of generation should be equal to summation of the demand. Okay, this is the power balance equation. Okay, summation of all generation should be equal to the demand. Okay, so that is, now what is this? We have decided that this is equal to lambda. In the previous slide you see this incremental cost is basically the Lagrange multiplier lambda. Therefore, what will be the generation? The generation will be equal to lambda minus BI divided by 2CI, right? Right? Is it? This is the Lagrange multiplier lambda or the incremental cost. From this equation, PGI is equal to lambda minus BI by 2CI. And from that equation 2, we know that summation PGI is equal to PD. So that means summation lambda minus BI by 2CI is equal to PG. Is equal to PD. Sorry, is equal to PD. Right? Fine. So that is given here. Summation lambda minus BI by 2CI is equal to PD. Okay. And from this equation we can separate. Okay. So lambda will come out minus summation BI by 2CI. This will be lambda by summation 2CI. Okay. that is equal to PD. Now from here we can get this equation. Okay, PD plus. So write down this equation. You write lambda PD plus summation Bi by Ci divided by summation 1 by 2 Ci. Okay, write down. Next you are going to use that equation to solve the economic disturbance problem. Right? Write this equation. The last equation, equation number 10. Equation number 10, all of you write. PD plus summation 1 to Ng Bi by Ci 1 to Ng 1 by 2 Ci. Done? All of you written? So now we will solve all the problems. See, your job is to solve all these three problems. Question number 2.1.1, 2 and 3. What was the equation in our case? The quadratic equation f is equal to ai. We started with ai, right? Bi Pgi plus Ci Pgi square. Right? Right? Sometimes the equation is given in other form. Then like Ci plus Bi Pgi plus Ci Pgi square. So accordingly you have to take the coefficients. Now in this case, what is A1? 1.5. A2? 1.1. B1? 20. B2? 30. Then C1 is 0.1 and C2 is also 0.1. Okay. Now your job is to find out the optimal schedule when the load is given, demand is given as 200. You have to find out the PG. Okay, PG. What is PG? How to find out PG? 1, that is lambda minus, you have written the equation in the previous slide. Lambda minus lambda minus T1 divided by 2C1. What is PG2? Lambda minus B2 by 2C2. But for that you need to find out lambda first. Okay? So what is lambda? PD plus summation
Bi by 2Ci
Bi by 2Ci
divided by summation 1 by 2Ci.
Do it. Find out lambda. Don't see the solution. Solution is there in the PPT. Don't see that. Find out the answer. The program for this is given in your power system lab. The first question in load flow and economic dispatch that you are doing in power system lab is for this question. Okay, a code is written for this. A for loop is written to compute this. Bhargav, compute.